Hello everyone, this is our third video on indices, and we've got to some of these more complicated ones with equations involving powers and indices, which is a very popular kind of question in GCSE and IGCSE, and we need to know in even A level as well. So let's have a look at a selection of these questions to get a feel for the idea of what's going on. So I'm going to do question 14C here. So let's look at 14C. So we have got 3 to the power of x add 4 is minus 27. So 3 to the power of x add 4 minus 27 is equal to 0. So the first thing I'm going to do is rearrange that, and I'm going to put the 27 over onto the other side. Okay. Now, the key idea with these questions is to get them so that you've got the same power on the left-hand side and the right-hand side. And 27 is a cube number. So 27 is actually 3 to the power of 3. So the first step is always to try and express them as the same base power. Once you express them as the same base power, then you can directly compare the indices. So in this case, I've now rewritten 27 as 3 cubed. So I can now directly compare these and say that x add 4 must equal 3. So therefore, x is going to equal minus 1 when I take the 4 off both sides. Okay, so that's the thing that we need to do. We need to directly compare the powers. Okay, right, let's do a little selection of these and we'll work up in levels of difficulty. Let's have a look at 14G now, G for golf. 14G says 9 to the power of x minus 2 is equal to, 27 again. Okay, now it might be, there's two ways we could do this. Well, let's think about it. I'm going to go for a power of 3 again. So we're going to have 27 is going to be 3 cubed. We're going to have 9 is 3 squared. And we've got to the power of x minus 2. So in this one, we're going to be using the fact that a to the power of n to the power of m is a to the power of n times m. Okay, so that means that this is 3 to the power of 2 times x minus 2 is equal to 3 cubed. Now that we've got to the stage where we've got the powers the same, we can now directly compare the indices. So we can now say that 2x minus 2 is going to equal 3. So we can expand that bracket. So we get 2x minus 4 is equal to 3. I'm going to add 4 to both sides. So 2x is equal to 7. And therefore x is equal to 7 over 2. Okay, so that's that one. Right, let's look at another one. I feel like J looks like it could be tricky. I'm just going to do a little sample of these just to help you get a feel for how they're working. And we're going to build up the level of difficulty of them as we go through. But I think if you've seen a few of them, you've been exposed to how a few of them work, then that's going to really help us. So we've got 3 to the power of 3x minus 2 is equal to the cube root of 9. Wow, that's a bit of a confusing thing. So the left-hand side's nice because the left-hand side's already in our required form, so we don't need to worry about anything there. It's really just the right-hand side. So we're going to think of 9 as 3 squared. That's our first step. And our second step is how are we going to represent something to the cube root? And the cube root is going to be something to the power of a third. Okay, so we've now got 3 to the power of 3x minus 2 is equal to 3 squared to the power of a third. Again, using our laws of indices, we can write that as 3 to the power of 2 times by a third, which is 3 to the power of 2/3. So we have 3 to the power of 3x minus 2 is equal to 2/3. So now we can directly compare the indices. So 3x minus 2 is equal to 2/3. And then we can say that 3x is equal to 2/3 plus 2. So we can work that out now. And then we're just going to divide the whole thing. So that gives us 8 over 3. So 3x is equal to 8 over 3. And then finally, we're just going to divide both sides by 3 now. So x is going to equal 8 over 9 when you divide both sides by 3. And that is how we would do that one. Okay, let's have a look at k, because we haven't yet dealt with one where we have a fraction involved. So let's look at k as well. This is 14k. Now 14k is 1 over 6 to the power of x add 3 is equal to 36. Now I'm going to use the law of thirds, that is 1 over a to the n is the same as a to the minus n. So I'm going to make use of that piece of information to rewrite 1/6 as 6 to the power of minus 1. So I've got 6 to the power of minus 1 to the power of x add 3 is equal to 36. And I'm going to think of 36 as being 6 squared. I'm going to use the law that a to the n to the m is a to the n times m. Now to write this as 6 to the power of minus 1 times by x add 3 is equal to 6 squared. And then from here, I can now expand that bracket. So I have minus 1 times by x add 3 is equal to 2. We can now compare the indices, which when I expand that bracket goes to minus x minus 3 is equal to 2. And I'm going to add the 3 over to the other side. So minus x is equal to 5. And then times by minus 1, I have x is equal to minus 5. Okay, that was that one. Right, that's good. So let's now build this up and have a look at some more that have got perhaps some more fractions and maybe something a little bit more complicated. Let's move on to question 15 now. And let's have a look at, let's see which ones look a little bit intriguing. I definitely feel like 15k and 15l. Let's have a look at those two. So 15k. Right, 15k is as follows. So we have a half to the power of 1 minus x is equal to an eighth to the power of 2x. So the first thing I'm going to do is use the law of indices here to represent these both as powers. Well, actually, no, even before that, I'm going to think of 1/8 as 1 over 2 cubed, because because 8 is a cube number, I can see that 2 is the base power that I'm going to be aiming for in this case. Now I'm going to use the law that 1 over a to the n is the same as a to the minus n. So now I can rewrite this one as 2 to the power of minus 1 times by 1 minus x is equal to 2 to the power of minus 3 times to the power of 2x. Again, I'm now going to use the law that is that a to the power of n to the m is a to the n times m. This means that this is now 2 to the power of minus 1 times by 1 minus x is equal to 2 to the power of minus 3 times by 2x. And then once I've got to this stage, I can now just write down the indices. So let me at this stage write down our indices. So we've now got minus 1 times by 1 minus x is equal to minus 3 times by 2x. Let's expand the brackets now and see what we get. When we expand these brackets now, we're going to get minus 1 plus x. So minus 1 plus x is going to equal minus 6x. And then from here, I'm going to add this 6x over to the left-hand side. So minus 1 plus 7x is equal to 0. I'm going to add that 1 over to that side. So 7x is equal to 1. And then finally, I'm going to divide by 7. So x is equal to 1 over 7 is our answer to 15k. Let's look at 15L. 15L, here we go. 15L, we have 1/4 to the power of x add 1 is equal to 8 to the power of x. So I know that 4 is 2 squared, and I know that 8 is 2 cubed. So again, I'm going to identify that my base power in this case is going to be 2. So I'm going to rewrite these using the laws that we've discussed earlier in our video today. I'm going to rewrite these as 1 over 2 squared to the power of x add 1. And I'm going to rewrite this as 2 cubed to the power of x. Now I'm going to rewrite 1 over 2 squared as 2 to the power of minus 2 times by x add 1 is equal to 2 to the power of 3 times x. And then finally 2 to the power of minus 2 times by x add 1 is equal to 2 to the 3x. And we've got to the stage now where the powers can be directly compared with each other. So we can now say that minus 2 open brackets x add 1 is equal to 3x. I can now expand that bracket, so minus 2x minus 2 is equal to 3x. Add the 2x over to the right hand side, so minus 2 is equal to 5x, and therefore x is equal to minus 2 over 5, minus rather 5 over 2. Let's have a look at that one. We're on 15L. No, minus 2 over 5, sorry, when we divide. So we get x is equal to minus 2 over 5 when we divide both sides by 5. Okay, so that's an introduction to how you tackle questions when they express them in that form. You can see that there's lots more of them there that you might want to have a go at yourself for further practice. But let's just have a quick look now at an actual GCSE question or IGCSE question. So this is taken from a 2024 paper, and there's various guises in which various ways in which this comes up, but in this particular instance it's come up with this type of format, and it says 2 to the x is equal to 2 to the n over the cube root of 2, and 2 to the y is equal to the square root of 2 to the 5. Given that x add y equals 8, work out the value of n. So we're going to use all the skills that we've been learning with indices over our last 3 videos, and we're going to apply them. So let's see what we've got. So we've got 2 to the power of x is equal to 2 to the power of n over the cube root of 2. Well, first of all, I'm going to rewrite the cube root of 2 as being 2 to the power of 1/3. So I've got 2 to the power of n over 2 to the power of 1/3. And that's equal to 2 to the x. Now, using the law that a to the n over a to the m is equal to a to the n minus m, using that law, I'm now going to rewrite this as 2 to the power of x is equal to 2 to the power of n minus 1/3. Okay, that's using the laws, this law here of indices that we've discovered in one of our earlier videos. Let's now turn our attention to the y1. 2 to the power of y is equal to the square root of 2 all to the power 5. So I'm going to rewrite the square root of 2 as 2 to the power of 1/2 to the power of 5, which is then going to be written as 2 to the power of 1/2 times by 5, using a to the n to the m is a to the n times m, using that law of indices. So therefore, our 2 to the power of y can now be expressed as 2 to the power of 5 over 2 when I multiply those together. And now we're in the position that we need to be, because we've got an expression. We can say from this expression that the implication of this is that x must equal n minus 1/3. So x is equal to n minus 1/3 from that equation. From this equation, we can say that y equals 5 over 2. So we have y is equal to 5 over 2. So now we can take these two expressions and plug them in to our x add y is equal to 8. So we have the x, which is going to be n minus a third. So n minus a third plus 5 over 2 must equal 8. So we can now just say that n must equal 8 minus 5 over 2 plus 1/3. Just rearranging the whole thing to get it over one side. And then 8 minus our 5 over 2 and plus 1/3 is going to give us 35 over 6. So n is equal to 35 over 6, which is our correct final answer. Well, I hope that you found that video helpful on the laws of indices. I'm sure that we'll be revisiting that a lot more in further videos, but I'll see you in the next video.